This is a problem from the American Invitational Mathematics exam. We're trying to find the value of this expression from these two equations. The first thing I'll do with the equations is factor them. So for the first equation, we have x to the power 4, y to the power 4 times x plus y equals 810. And x cubed, y cubed times x cubed plus y cubed equals 945. If we divide the second equation by the first equation, we'll get x squared minus xy plus y squared over xy equals 945 divided by 810, which is equal to 7 over 6. This is because x cubed plus y cubed equals x plus y times x squared minus xy plus y squared. So now that we have this equation, if we add 3 to both sides of this equation, right here, we get x squared plus 2xy plus y squared over xy equals 7 over 6 plus 3 equals 25 over 6. We can factor this to x plus y squared over xy equals 25 over 6. We can solve for x plus y by multiplying both sides by xy and then taking the square root. So here I take the square root. Alright, so now that we have x plus y, we can substitute this in this equation right here. So we have x to the power 4, y to the power 4, x plus y equals 810. So now we have x to the power 4, y to the power 4, times 5 root 6 over 6 root xy equals 810. And we can rearrange this to be x to the power of 9 over 2, y to the power of 9 over 2 equals 810 times square root 6 over 5. So this would be x to the power of 9 over 2, y to the power of 9 over 2 equals 162 root 6. In solving for xy, we get xy equals 3 cube root 2. So here we wanted to get 2x cubed plus x cubed y cubed plus 2y cubed, and we can get x cubed y cubed by taking this to the power of 3, which would be 3 cubed is 27 times 2, 54. And we can calculate 2x cubed plus 2y cubed by using this equation right here. I'll bring it over. X cubed y cubed times x cubed plus y cubed equals 945. And because of this, we have x cubed plus y cubed equals 945 over 54, which is equal to 35 over 2. And that means 2x cubed plus 2y cubed equals 35. So 2x cubed plus x cubed y cubed plus 2y cubed equals 35 plus 54, which is equal to 89, which is the answer to this problem.